Hello, in this video we're going to derive short-run costs from a Cobb-Douglas production function that displays constant returns to labor. Here is our Cobb-Douglas production function, Q equals L times K. We're going to derive short-run costs, so K is going to be fixed. Our level of capital will be fixed in the short run, and we're going to fix it at 2. I could have picked any other number, but 2 is as good as any. We're going to assume that the wage is $20. And the price of capital, R, is $100. We're going to derive all 7 of the firm's short-run costs. Step 1, we're going to substitute our fixed level of capital into the production function. So where we have K, we will plug in 2. So our production function, short-run production function, now is the quantity of output equals 2 times L. Note there are constant returns to labor. Every added worker increases output by 2 units. If we were to take the derivative of this production function with respect to labor, you would get marginal product, and it would just be 2. Every worker, again, adds 2 units of output. Every worker hired adds 2 units of output. So the next step here is to take our production function and solve it for L. So Q equals 2L. We're going to solve that for L. And L equals Q divided by 2. Once we got L equals Q divided by 2, we move to step 3, and we're going to create the total cost function, and then we're going to make a bunch of substitutions. So total cost is variable cost plus fixed cost, where the variable cost is the wage times the number of variable inputs, labor being our variable input, and fixed cost will be the price of capital times the fixed units of capital. First thing I do is I'll substitute in the wage of $20 and the price of capital of $100. The next thing I'll do is for L, I'm going to substitute in Q divided by 2. And for K, we said we're going to fix K at 2. So making those substitutions and now simplifying, we're going to get total cost equals 10Q plus 200. 200 is the fixed cost, 10Q is the variable cost. One thing to note here is if we were to take the derivative of the cost function, the total cost function, you're going to get 10. So the slope of total cost is constant. Every time we produce one more unit of output, total cost goes up by $10. And the shape of the total cost here comes about due to what's going on with returns to labor. In this case, we have constant returns to labor. Okay, step 4, we're going to derive the remaining 6 costs of the firm. As I mentioned before, variable cost is just as 10 times Q. And also notice here that the slope of variable cost is just constant. The slope here is just 10. It's just going to be a straight line from the origin with a slope of 10. Fixed cost is just 200. Average cost we'll get by taking our total cost function and dividing it through by Q. So 10Q divided by Q is 10. And 200 divided by Q is 200 divided by Q. So that is our average cost, the cost per unit of output. When Q gets really big, average cost approaches $10, or as we're going to see, it approaches average variable cost. So when Q gets very big here, okay, average cost will basically start approaching $10. So average variable cost, we're going to just take variable cost and divide it through by Q. So 10Q divided by Q leaves us with average variable cost equal to $10. Average variable cost will be horizontal. If you were to graph it, it'll just be horizontal at a value of $10. Our average fixed cost is going to be fixed cost divided by the quantity. So fixed cost was 200. I'm just dividing that through by Q. We get average fixed cost. You'll note here that as Q gets bigger, average fixed cost gets smaller and smaller and smaller. This will always be a property of average fixed cost. And finally, marginal cost. For marginal cost, we're going to take the derivative of the total cost function with respect to output, which will also equal the derivative of the variable cost function with respect to output. In this case, we get $10. So marginal cost will be constant at $10. It'll be horizontal, just like average variable cost. So in this example, marginal cost is constant or horizontal at $10 because of constant returns to labor. Marginal cost would slope upward if we had decreasing returns to labor, but we don't have this in this example. And marginal cost would slope downwards if we had a situation where there were, at least temporarily, increasing returns to labor. Again, we don't have this in our example here. We just have constant returns to labor, so marginal cost will be a horizontal line. Will be constant at $10.
One story, this is another story. Eventually, I think they come together.
And another point here, average variable cost will equal marginal cost if we have constant returns to labor.